Hello everyone. I'm starting with a standard router that I no longer use. It's a typical design with two antennas, an array of ports at the back, and ventilation grills on the sides. I'm going to use a screwdriver to carefully remove all the screws holding the casing together. This will allow us to access the internal components for our modification. With all the screws removed, I can now gently pry open the router casing. I'm being careful not to damage any internal connectors or wires that might be attached to the top cover. You can already see the main circuit board inside. This is the heart of the device, and we need to work with it gently to avoid any static discharge or physical damage to the delicate components. I'm having two insulated wires, one red and one blue. These will be crucial for connecting our new components to the router's power supply on the board. Next, I'm applying solder to secure the red wire to the circuit board. A good solder joint is crucial for a reliable electrical connection. Now, I'm repeating the process with a blue wire. Just like before, I'll secure this connection with solder to make sure it's robust and functional. With both the red and blue wires securely soldered, you can see how they extend from the circuit board, forming the primary power leads for our repurposed device. It's time to place the modified circuit board back into the router's lower casing. I'm carefully routing the red and blue wires through an opening to the outside. This allows us to access them for external connections while keeping the internal components protected. With the board in place, I'm reattaching the top cover of the router and securing it with the original screws. This step ensures that the internal components are properly housed and protected, and the router retains its original form factor. And there we have it. The router is now fully reassembled with our red and blue power wires extending neatly from the side. Let's introduce our next component, a small speaker. This speaker will serve a very specific, unexpected role in our project. I'm showing you its front, its back, and pointing out the terminals where we'll make our connections. I'm taking a yellow Ethernet cable and carefully stripping away its outer jacket to expose the inner wires. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. The individual wires inside will be essential for establishing our signal connection. From the exposed Ethernet cable, I'm selecting two individual wires and stripping their insulation. These fine copper strands are what we need to carry our signal. With the insulation stripped, I'm gently twisting the fine copper strands of the wire together. This makes the connection more robust and prevents stray strands from causing short circuits. To make sure these connections are strong and stable, I'm using my soldering iron to secure them in place. Good soldering ensures excellent sound transmission without interference. After soldering, I'm applying a generous amount of hot glue over the soldered joints and the exposed wires on the speaker. This not only provides insulation and prevents short circuits but also adds mechanical strength, keeping the wires firmly attached to the speaker terminals. The speaker is ready for integration into our main router unit. You can see how cleanly the wires are connected. I'm taking the Ethernet cable attached to the speaker and plugging its end directly into one of the Ethernet ports on the back of the router. This provides the crucial data and power connection to activate our new functions. I'm taking the speaker and firmly pressing it onto the top of the router, securing it with hot glue. This permanent attachment turns the router and speaker into a single cohesive unit for our smart TV setup. I'm now focusing on the red and blue wires extending from the router. I'll take the blue wire first and strip a small section of insulation from its end, just like before, to prepare it for its next connection. I'm doing the same with the red wire. Stripping its end ensures that we have clean copper ready for an electrical connection. I'm taking a standard wall plug and disassembling it to access its internal terminals. This will allow us to connect our power wires directly. I'm twisting the stripped end of the blue wire tightly around one of the metal prongs from the wall plug. Then, I'm using the screwdriver to firmly secure the connection. A tight connection is essential for safety and conductivity. I'm repeating this for the red wire, twisting it onto the other metal prong and then tightening it with the screwdriver. Now both prongs are connected to our router's power leads. I'm reassembling the plastic casing of the wall plug around the wired prongs. I'm making sure all the wires are tucked in neatly and securely, preventing any exposure or accidental short circuits. I'm tightening the main screw on the wall plug to completely secure the casing and the internal components. This ensures the plug is safe to handle and use. Moving on to the next component, I'm taking a wall socket and using a screwdriver to remove its faceplate. We'll be working with the internal wiring of the socket for our next connection. I'm taking a section of black cable and carefully stripping away a portion of the outer black insulation. This exposes the internal wires that we will use to connect to the wall socket. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I will strip a small section of its insulation to expose the central copper core, preparing it for connection to the wall outlet connector. I will fix the central copper core to one of the wall outlet pins. I'm tightening the screw firmly with my screwdriver, ensuring a very secure connection for the white wire. I then secured the braided cover to the remaining plug pin. This minimizes resistance and maximizes signal integrity for our setup. After making the connections, I'm reassembling the wall socket's cover and tightening the screws. This prepares our socket unit to receive the antenna signal. To protect the connection where the cable enters the socket, I'm sliding a piece of heat shrink tubing over it and carefully heating it with a lighter. This shrinks the tubing tightly around the cable, providing excellent insulation and strain relief. I'm taking the other end of the black cable coming from the wall socket. I'll carefully strip away the outer black insulation, exposing the internal wires once again. This is where we'll attach our coaxial connector. I'm taking a coaxial F connector and carefully attaching it to the prepared end of the wire. This connector is crucial for sending the TV signal to our television set. For the TV connection, I'm taking a right-angle F-type connector and securely attaching it to the stripped black cable. This type of connector is ideal for tight spaces behind a TV. And there you have it. Our complete custom-built antenna system, made from a repurposed router, is finished. As you can see, initially, the TV shows no signal, just as expected. This confirms we're starting from a blank slate with our new device. I'm connecting our new antenna setup to the back of this television. The TV instantly picks up a signal, and we have a crystal clear image. Our repurposed router is acting as a powerful antenna, bringing in free TV channels. I'm using the TV remote to cycle through different channels, demonstrating how smoothly the signal transitions. It's truly incredible how this old router can now provide a reliable and free television experience. Let's try a few more channels. The picture quality is excellent, proving that this DIY antenna is highly effective. It's like magic, but it's just clever engineering. The vibrant colors and clear audio are all thanks to our transformed router. To really show you the difference, I'll disconnect the antenna. See, no signal immediately returns. But once I reconnect it, bam! Instant channels. It's working exactly as intended. This amazing device truly delivers. And there you have it. Our incredible multifunctional device, made from a simple old router, transforming a regular TV into a smart TV with a working antenna and speaker. If you enjoyed this project and found it inspiring, please give this video a big thumbs up, share it with your friends, and leave a comment below telling me what other unexpected tools you'd like to see me create. Don't forget to subscribe for more fantastic DIY ideas. Thank you for watching, and I'll see you in the next one.